Welcome to Algebra 2. Today what we're going to be talking about is Chapter 10, Day 11, which is really going to be finding the probability of the complement of an event. So we'll discuss what the complement is and how to find it. And other problems in this is just going to be review problems from before. Okay, so if we take a look at these two review problems, we want to find the probability that a randomly selected number between 1 and 50 is even. Okay, that's the amount of even numbers between 1 and 50, which is just going to be 1/2. So that's what we get when we simplify. 1/2, 0.5, or 50%. All right, for number 2, a number that is less than 21. All right, so that would be 1 through 20. So there's 20 numbers there. Out of the 50, that's 2/5, which is 0.4, or 40%. Okay. Next, we got 2 more. In case 3, it says the ski club with 10 members is to choose 3 officers: captain, co-captain, and secretary. How many ways can those offices be filled? All right, we're going to take some assumptions into play here. Of those 10 members, let's just say the person who receives the most amount of votes is going to be captain, the next co-captain, the next is secretary, and so on. So if we think about that, we got 10 members to choose from. All right, the amount of people that could be captain is going to be 10. But then once that person's chosen as captain, we got 9 people for co-captain. And then once that person's chosen as co-captain, we got 8 people left for secretary. All right, so if we multiply those, we get 720. 720 different ways those offices could be filled. All right, for example, example 4, it says there are 12 standbys who hope to get on your flight to Hawaii, but only 6 seats are available on the plane. How many different ways can the 6 people be selected? So in this one, we have to think back to permutations and combinations. So we have to think, is this a permutation or is this a combination? All right, in this case, that means we just have to figure out, does order matter? Or does order not matter? All right, and most of these times, we have to look at the question that's being asked. All right, so how many ways can the 6 people be selected to fill those seats? Okay, in this case, they just want to get on the plane. You know, maybe they don't really care what seat they're in. We're just trying to figure out, there are 12 standbys. They're just hoping to get to Hawaii. Okay, they want to get on the plane. So in that case, it's a combination. So of 12 people, we're figuring out the amount of groups that can be made if we select 6. So that's 12C6, which would be 924. All right, so let's get to it. So today, what we're going to be talking about is the complement. Okay, and we're still going to be talking about unions and intersections of events. We're still going to go over some geometric probability, but that's the main deal that we're going to be talking about. All right, your homework is just going to be the Day 11 worksheet. So let's get going. So the complement of an event consists of all outcomes that are not in the event. Okay. For example, if an integer from 1 to 10 is chosen at random, the complement of the event, the integer is even, is the integer is odd. So it's just the opposite. Okay, so to figure out the complement of an event, all right, we could take a look right here. All right, the probability that A doesn't happen, which is what that's saying, is just equal to 1, which is just all the possible outcomes, minus the outcomes in which event A actually happens. Okay, so the probability that A doesn't happen would just be 1 minus the probability that A does happen. Okay. So if we know that the probability of A is 0.53, we can figure out the probability that A doesn't happen, which is just what's meant by not A. Okay. The probability that A doesn't happen is just going to be 1 minus 0.53. So it's going to be all the other cases, which would be 0.47. So if the probability that A happens is 53%, the probability that it doesn't is 47%. Seems pretty intuitive. But we also got to deal with some fractions. Okay, so the probability that A happens here is 7/9. So the probability that A doesn't happen is 1 minus 7/9. 1 is just 9 over 9 in this case. This is all of the outcomes. 9 out of the 9. Okay, so that would leave 2 outcomes remaining. Hopefully this makes sense right now. Let's get a little bit more concrete with what we mean by a complement. All right, so when two six-sided dice are rolled, 36 outcomes are possible, as shown. So we've got, let's say, a white die and a blue die. Okay, if we're looking at all the different combinations of what can happen here. Obviously, for the white die, we could get a 1, 2, 3, 4, 5, and 6. Okay, for the blue die, it's the same thing. We could get a 1, 2, 3, 4, 5, and 6. All right, so that's why we got 36 different outcomes that are possible. All right, the die that's white has 6 outcomes. The die that's blue has 6 outcomes. 6 times 6 is 36. All right, so if we want to find the probability that the sum is not 2, okay, we could just start by counting all those different times the sum is not 2. All right, but a lot of cases, it's a little bit easier to think about the complement of an event with respect to an event like happening. All right, so the probability that the sum is not 2 is just 1 minus the probability that the sum is 2. All right, and in this case, I mean, that's really easy to count. There's one case in which the sum is 2. All right, so we have 1 minus 1 out of 36, which would be 35 out of 36. So in this case, it was easier to count like how many times that does happen and put it into perspective in terms of how many times it doesn't happen. All right, same is true for part B. If we take a look, it says the sum is less than or equal to 10. Of course, once again, we could just add up all those that are less than or equal to 10. Okay, or we could think about it as, so I'm just going to write the probability that the sum is less than or equal to 10. We could think about it as the probability that it's greater than 10. So the probability that it's less than or equal to 10 is just 1 minus the probability that it's greater than 10. So now all we got to do is count up all those cases in which it would be greater than 10. In this case, it's only 3. We get a 5 and a 6, or 2 6s. It's 3 outcomes. So it's much easier to count those 3 outcomes than all the other outcomes that are less than or equal to 10. All right, so if we subtract that, we get 33 out of 36. And that's it. So a lot of times that's a little bit easier. So we can think of a lot of cases in which it's easier to figure out how many ways can this not happen or how many ways this can happen to figure out the probability that we're really looking for. All right, so going back to disjoint and overlapping events. Remember, for disjoint events, they both can't occur at the same time, and in that case, we just add them up. All right, the probability of event A plus the probability of event B would be 0.7. And if they're disjoint, there's no overlap. All right, same thing with our fractions here. Let's just add them up, and we get 4/5. All right, so that's the probability of event A or B occurring if they are disjoint. But remember, if they're overlapping, we've got cases in which they can both happen at the same time. So for cases in which they could both happen at the same time, we might need to set up this equation. So if we set up this equation, and I'm just going to rewrite it here, probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. If we set up our equation, we could just plug it in. Notice though in this example, we got percents, we got decimals, so we just got to make sure to be consistent. All right, if you want to use percents, use percents. All right, 0.27 is 27%. So now let's plug everything in. All right, maybe it's a little bit easier to deal with whole numbers. Oops. minus. If it's easier to deal with whole numbers, use those whole numbers. All right, we can just combine like terms here. That'd be 55. And like I said before, we can skip some steps. All right, so if we want to figure out the probability of A and B, okay, we just need to find the difference between these two. Okay, the difference between those two would be 28. So the probability of A and B occurring is 28%. If you used decimals, that would be 0.28. All right, let's scroll back up to the fractions. Our favorite thing, fractions. Yay. Especially with these, where all the denominators are not the same. So the first thing that we do before we do anything, we should just make sure those denominators are the same. All right, so if we look for, the least common multiple here, 4 times something, 6 times something, 9 times something, where they would all be the same, okay? 36 would be that lowest common multiple. So if we start with 5/9, okay, to change that, we'd multiply by 4 over 4, and we'd get 20/36. If we take a look at 1/4, okay, to change that denominator to 36, we'd have to multiply by 9 over 9, so we get 9/36. All right, for 1/6, okay, to get that to be 36, we just multiply by 6 over 6, so we get 6/36. And now we can plug it into the equation. So I'm going to skip this first step of writing out the actual equation. So make sure you're listening. So the probability of A or B is 6/36. That's going to equal the probability of A, which is 20/36, plus the probability of B, which is 9/36, minus the probability of A and B. I'm running out of space here on the board, so I'm just going to put X. That's what we're looking for, the probability of A and B. Now let's combine. So we'd get 29/36. Now if we just find the difference here, that'd be 23. So the probability of A and B occurring is 23 out of 36. There's a lot of overlapping events there. All right, next in example 5, we have a standard deck of 52 cards. We're going to select one from that deck, find the probability that it's not a king. All right, so once again, instead of counting up all those cards that are not kings, which would be very time consuming, let's just put it into perspective with the probability that it is a king. Okay, we know that there's 4 kings. All right, so the probability that it's not a king is just 1 minus the 4 out of 52 cards, those 4 kings out of 52. All right, so that's really 52 minus 4, which is 48. So if there's 4 cards that are kings, there's 48 cards that are not kings. All right, if we simplify, that's 12/13, or 0.923, which would be 92.3%. For these more realistic examples, I always like to figure out the percent so we can relate. In example 2, we want to figure out the probability that it's a 5 or a 9. All right, in this case, we know how many 5s there are. We know how many 9s there are. So that's 4 out of 52 plus another 4 out of 52, and that would be 8 out of 52. Okay, so if we simplify that, that'd be 2/13, which would be 0.15 or 15%. All right, in this one, look at this. It says and. All right, that's one of the first examples that we've been doing with these card examples where it says and. Okay, so this says find the probability of drawing a queen and a diamond. So now we're just looking for the intersection. Hey, look at that. There's our 1 queen of diamonds. So that's 1 out of 52. Okay? So if we simplify that, 1 second, for some reason I did not have that written down. I believe that's 0.019. Let me double check. Did not have my calculator. Yeah, 0.019. Okay. So 0.019 or 1.9%. All right, then for 4, a face card and a 7. Okay, in this case, the probability of drawing a face card and a 7. Huh. That can't happen at the same time. That's a big old 0. We can't draw a face card and a 7. All right, so that's it. So in terms of this example, part 4, the probability of drawing a face card and a 7, so those two events are disjoint. Okay, so if we were thinking the probability of drawing a face card or a 7, that would be a different scenario. But since it says and those events are disjoint, that's why we got 0. All right, example 6, you and your friends are trying to get jobs at Taco Bell. You estimate that there's a 60% chance that you will get the job. Also, you estimate that there's a 25% chance your friend will get the job. How do you know that? Who knows? What is the probability that either you or your friend will get the job? Okay, so in this case, we have to think, is this overlapping? Is this disjoint? It really depends on the phrasing of the question here. In this case, it's saying the job. Your friend, percent chance you will get the job or your friend will get the job. Since it's saying the job, I'm guessing one job is available. So that means that you both can't get the job. So that means they would be disjoint. So that just means we add them up. So we get 85%. So 85% chance, you or your friend gets the job. Okay. A couple more examples. Here we go. This says you have an equally likely chance of choosing any integer from 1 through 10. Find the probability that we get a number less than 4. Okay, so how many numbers are there less than 4? From 1 through 10, there's 3. So that's 3/10, 0.3, or 30%. The probability that a multiple of 2 is chosen. Okay, so that would be, if we need to list it out, here's our multiples of 2. So that's 5 out of the 10, which is 1/2 or 0.5, 50%. In example 8, we're doing that geometric probability. So to just make sure to refresh, the probability that a randomly selected point is going to lie in the shaded region is going to be the area of the shaded region divided by the area of the total figure. The area of the shaded region, as we can see, is that smaller rectangle. The area of the total region is going to be that big rectangle there. So we could just rewrite this in terms of little and big. So we got the area of the little figure plus the area of the big figure. And the area of the little figure is just 5 times 8. The area of the big figure is 11 times 12. All right, so let's simplify. 5 times 8 is 40. 11 times 12 is 132. Okay, and if we just type that into our calculator, we get 0.3 or 30%. All right, last problem here. In example 9, the probability that a student participates in math club is 5%. Let's say the probability that a student participating in key club is 10%. If the probability that a student participates in math club or key club is 11%, what's the probability that they participate in both? Okay, so once again, I'm going to write down the equation, but in this case, I'm going to use M and K for math club and key club. The probability that a student participates in math club or key club is the probability that they participate in math club plus the probability that they participate in key club minus the probability that they participate in both, which would be the probability of M and K. We know that there's some overlapping here. Okay, 5 plus 10 does not add up to 11. All right, so the or was 11%. Math club was 5%. Key club was 10%. And we're just figuring out what is the intersection here. Okay, what's the probability that they participate in both? Like I said before, the math doesn't add up here, right? We had 15 and we had 11. We can just find the difference. So I'm writing all this work, okay, when really we could just find the difference. So these might be a little bit quicker when you do them because you're going to add up the two independent probabilities, subtract off the probability of M or K, and we just get 4. All right, folks. Like always, email me if you have questions, and have a good day.